Any numerical you solve?
Yes, sir. Yes, sir. Doubt, sir.
Doubt is there. So
Yes, sir.
first let us see the doubts only. After that, let me bring the book. Yes, which number?
Sir, number 23.
Number 23.
23. Yes, sir.
Okay. Before that, dielectric is also coming. Any other? That we'll do after doing dielectric one. Any other?
And sir, one more, sir.
Yeah.
31.
31. Okay. 31 we are doing now. So 31 you are given. Figure 5.64. Okay, these are the figures. 4 capacitor, 100 microfarad. Each voltage rating is 10 volt. Out of the following quantity, which of the value will be same? Okay. So first one is when it is connected like this, each can bear a voltage of 10 volt. 10 volt, 100 microfarad. That is the value. 100 microfarad and voltage rating 10 volt. Okay, so you have to find a effective capacitance, voltage rating, and maximum energy of the system that can be stored. Calculate its value also. Okay. So what is equivalent capacitance? So what will be CAV? All are in series. So 100 microfarad over 4, they are equal only. So it is 25 microfarad. What will be the potential difference maximum? Maximum potential difference between A and B. It can be a 10 volt, this 10 volt, this 10 volt, this 10 volt. That is from here to here, maximum potential difference can be 40 volt. Now, what is the energy stored? Total energy stored will be half CAB into VAB square, half CV square, the equivalent capacity and potential difference. So that is half into 25 microfarad, and this one will become 1600. This one joule. 40 square. 25 is that 200. So 2 into 10 to the power minus 2. No.
Yes, sir. Answer is that only.
Yes?
So the answer is 0.020 joule. That is only.
Yeah, 0.02 joule. So 2 into 10 minus 2. So when it is connected this way. Now second one is connection is two capacitor is coming this side and two capacitor is coming this side. So this is point A, this is point B. This is 100 microfarad, and each can bear a maximum voltage of 10 volt. So now what will be equivalent capacity?
10 only, I guess.
Huh?
Sir, 100 only, I guess.
So these two are in series.
Series.
So it is 50, 100, 100 series. So 50
Yes, sir.
is also 50. So what will be?
100, sir.
100. So it is 100 by 2 plus 100 by 2. So 100 microfarad. What will be the maximum voltage between A and B? So it can be a 10 volt, this can be a 10 volt. That is maximum. From here to here it may be 20 volts. If you increase more than 20, anyone will be damaged.
Yes.
More than suppose 25, that means someone will go to 12, some 13, or one is 15, other is whatever it is. As they are equal, so equal will be divided. So 12.5 here, 12.5 here will come. So naturally both will be damaged. So maximum voltage between A and B will be 20 volt. What will be now? What will come? 10. Now third one is
10 volt.
parallel. So what will be now? This point A, this point B, so all are in parallel, so it will become 400. Maximum potential difference
10.
only 10 volt. So energy will be again same. So energy stored will not change whether you are connecting capacitors in parallel or series. Yes, any other?
Sir, number 10.
Number 10.
Yes, sir, that one only I was working.
Number 10 is a 5 microfarad capacitor is charged to 220 volt supply. It is then disconnected from the supply and is connected to another uncharged. Okay, this one we'll do afterwards. We'll do the sharing of the charge. Afterwards we'll do. Okay, let us finish first whatever the part is left. And tomorrow you ask the remaining problems. So two topics we have to discuss. One will be when the dielectric slab is inserted or when a thin plate of dielectric is inserted between the capacitance, what will be the equivalent capacity, and after that when two conductors are connected or two capacitors are connected, what will be the common potential, what will be the energy loss, which is asked in number 5. That one we will do. That part is left. Okay. So first will be capacity of parallel plate capacitor. When a dielectric slab is placed. So yesterday we have seen what will be the effect when dielectric slab is placed in electric field. So inside the dielectric slab, electric field decreases, and the factor by which electric field decreases, that factor we call dielectric constant. So suppose this is a parallel plate capacitor. So this is connected to the positive terminal of the source. This is connected to the negative terminal of the source. Area of the each plate is A, and distance between these two plates is D. So here uniform electric field will be created. So this is the E naught, suppose. And what will be E naught? So this E naught is how much? Sigma over epsilon naught, that is U over A epsilon naught. Sometimes this derivation is off, so you have to know how to derive. Now suppose we have inserted a dielectric slab of thickness T. So here also E naught, but inside the slab, the electric field will be less than this one. So inside the slab, suppose electric field is this one. Okay. So EM is the electric field inside, because E naught is much more than whatever electric field is induced here. Induced electric field will be less than the external electric field. And what was the relation between EM and E naught? So this EM is E naught over K, where K is the dielectric constant of, or dielectric relative permittivity of that slab. Now, what will be the equivalent capacity of this capacitor? So, if derivation is asked, same will proceed. Let us consider a parallel plate having plate area A, each plate having area A, and the separation between the two plates is D. Let a dielectric slab of dielectric constant K be inserted between these two plates. So electric field outside the slab will be E naught, and that is given by this one, whereas electric field inside the slab will be EM, and this is E naught over K, so it is Q over K A epsilon naught. Or sometimes we say epsilon naught epsilon r. If we say the dielectric constant, the relative permittivity is epsilon r, and epsilon naught epsilon r we say. Okay. Now what will be the, because we are interested to find the capacity, and capacity is what? Q by V. So what is the charge given? We have assumed that if the charge is given is here plus Q, and this is minus Q, and we will find what is the potential difference.
So,
Yes.
so inside that dielectric constant, you are giving the direct electric field or the net electric field direction.
That is net electric field.
Net.
Study we did, no?
Yes,
Induced electric field will be opposite.
yes, that's what I was asking. It's net.
It is net electric field.
Yes.
Net electric field inside the slab will be EM, and that is given by E naught over K. So what will be the potential difference? Suppose this we are saying it is D1. This is D2. And this is T. So what will be the potential difference between the plate? Two parallel plates. This V is how much? So it is E naught into D1. And electric field is uniform, so potential difference E into D. We can't use E into D because here electric field is different. So E naught into D will not be taken. So this one from here to here. So it is this much. Now plus EM into T. Potential difference from here to here because electric field intensity in same direction. So this will be higher potential, this is lower potential. This is higher potential, this is lower potential. Again, this is higher potential, this is lower potential. Plus E naught into D2. Yes, any confusion? E is minus dV by dr. So dV is E into dr. Here E is constant, so E into whatever r distance will be there. So it is E naught D1 plus D2 plus EM into T. Now this is E naught. Can we write this D1 plus D2 as D minus T?
Yes, sir.
So this is D minus T. In place of EM, we are writing E naught over K into T. Yes. So suppose this is E naught we are taking common, then what is that? D minus T plus T by T. Yes, no confusion? Now we are substituting the value of this E naught from here. So Q over epsilon naught A or A epsilon naught, whatever you write, D minus E plus E by A. Now what will be the capacity, which is Q over V, will be epsilon naught A D minus E plus E by A. So if you are asked to derive, you have to derive up to this place. So when any slab is inserted, it is not completely filled. If it is completely filled, we are knowing. So it will become epsilon naught epsilon R A by D. So K times it will increase, or epsilon naught R times it will increase. But here it is completely, it is not filled, only small part is filled. Now suppose many slabs are inserted. Now you see this formula. I will recall it. So suppose this is D minus T by we are writing 1. That is air of thickness of air is D minus T and dielectric constant of the air is 1. So whatever thickness of air divided by dielectric constant of that. Whatever thickness of plate divided by dielectric constant of that plate. So if many plates are inserted, so suppose this is the one plate this much, other plate is this much, third is this one. So on this plate we are giving plus Q, this plate we are giving minus Q. This is dielectric constant, suppose K1, thickness is T1, this is T2, dielectric constant K2, this is T3, this is T4, many more may be inserted. Then what will be? Electric field here, it will be E naught over K1, E naught over K2, E naught over K3, E naught over K4. So potential difference will be what? E naught over K1 into T1, E naught over K2 into T2, E naught over K3 into T3, K4 into T4. E naught if you are taking common, so Q over epsilon naught A will be common. What is left? T1 by K1 plus T2 by K2, T3 by K3, plus so on. If so many are there, then we keep on like this. So if many slabs are inserted, then this C will be how much? Q by V. So what will be coming? Epsilon naught A by this whole Q1 by K1 plus T2 by K2. So it is epsilon naught A T1 by K1 plus T2 by K2 plus T3 by K3 plus 4. Here it may be, suppose this one is A only, this one is metal, no problem. We can use this formula. Only suppose this one plate is here inserted, maybe of glass, this plate is of in mica, this is air, this is metal. What will come? So K1, K2 value will be given, K3 will be 1, K4 will be infinity. Once metallic plate inserted means, so for air value of K is 1 and for metal it is infinity. So for air K is 1 and for metal or metallic plate value of K will be inserted as infinity. So this is the general formula of parallel plate capacitor. If only air is there, then that is d by 1 only. So epsilon naught A over d. If the whole is of only one material, epsilon naught A d by k. So k will go up. Epsilon naught epsilon r or k A by d, that we have already done. So this is the general formula for parallel plate capacitor. Now, sharing of charge and potential and loss of, oh no, time is up, 9:40 already. Okay, then let us see one numerical only. How will you solve this? Suppose sometime it will be given, this is a parallel plate. Area is A, distance is D. Now, only 50% of this area, a dielectric slab is inserted. And you will be asked, what is the equivalent capacity? In this situation, we will treat it as two different capacitors. So we will treat it as two different capacitors. Here, this is suppose A by 2 area and dielectric is present. Another is this one, which has got air only. And 50% area is, that is here this one. Now how these two are connected?
Parallel.
Metallic plate, so they are connected this way. So what is the equivalent capacity? Epsilon naught A by 2 d by k plus epsilon naught area is A by 2 by d. So this way it will be. Now, sometimes in this part only there will be two different dielectric. D by 2 is this K1 and D by 2 is this K2. Now what will be the situation?
If of the two capacitors will consider as series, and then those two series will be with the down one in the parallel.
Is this two capacitor?
Series.
No, it is not two capacitor. Two metallic plates are not there.
Oh yeah.
It is the capacitor having composite slab. So what will be the capacity of one? So D by 2 K1 plus D by 2 K2. Epsilon naught A by T1 by K1. That is the formula, general one. So it will be epsilon naught A by 2, area is this one, and half of this one, that is D by 2, is having dielectric constant K1, rest half is K2. Now this and this are in parallel. So we'll solve that way. So this way we have to think. Sometimes it will be given this way, some other way, different. Okay, now tomorrow we shall finish that topic. Sharing of the charge when the two capacitor or conductor are connected, and then loss in energy. Okay, shall we leave up to here?
Yes, sir. Thank you.
Yes, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Very fast.